So from these pictures in here, don't really worry about 12 so much or factoring specifically. You just need to remember to know how to factor a trinomial and grouping, as it helps sometimes. But there's other ways of doing the problems, like using synthetic division and stuff. But again, make sure you can factor a trinomial, like x squared plus 5x plus 6. Well, multiplies to 6, adds to 5, right? 2 and 3, x plus 2, x plus 3. So if those are factors, your x-intercepts or zeros would be x is negative 2 and x is negative 3. That's really what's important. But don't worry about cubes and grouping. Okay, for a problem that says divide using synthetic division. So they say take this long expression, so we put all the numbers here, and divide by x plus 2. Now, since it says x plus 2, the number that we put on the outside is a negative 2, right? And we do our synthetic division. All the coefficients go on top, right, and the constant. Add inside, so 4 plus nothing is 4. Multiply outside, 4 times negative 2 is negative 8. And negative 8 plus 6 is negative 2. Negative 2 times negative 2 is 4. 4 and negative 6 is negative 2, so on and so forth. Now at the very end, we don't have a 0. That means there's a remainder. We were not told that x plus 2 was a factor. It just said divide by x plus 2. So it doesn't need to go in evenly. That's okay that we have a remainder. So if it says, here's your original expression, divide by x plus 2, they want to know what's left. So we use all these numbers on the bottom to write the polynomial expression that remains. So 4 drops a degree, so 4x to the 4th minus 2x cubed minus 2x squared plus 5x minus 13. Now the 6 is the remainder, so for the remainder we write a plus 4 and whatever number's left, so 6, all over whatever you were dividing by, in this case x plus 2. That's your final answer. You can't factor further. It just said divide. So this is your answer. Don't worry about number 13. I won't give you 1 degree 5. But you're doing what you were doing before. You would plug this into your calculator, right? You can pretend it's y equals. And then you would find an x-intercept. So if I saw it cross at negative 2, I do synthetic division. Then it drops a degree, so I'm left with this new expression. I see that the original touches the x-axis at 1, so I do synthetic division, always working with your newest equation. Then the remaining expression drops a degree, so now we're left with 1x cubed. And if at any point you can factor, go for it. So I was able to factor by grouping. I grouped my left pair and my right pair. And once I got my factors, I set each factor equal to 0 and solved. So that's why I got plus or minus I and 2. But don't worry, you won't have 1 degree 5. Okay, this last part, number 14. If it says that 0, negative 1, and 3 are root zeros, x-intercepts, you say x equals 0, x equals negative 1, x equals 3. Those are the x-intercepts. So to write them as factors, you need to bring the number on the same side as x and put parentheses around. So I would subtract 3, put in parentheses. Add 1, put in parentheses. Add or subtract 0, it doesn't matter. X minus 0, you can leave it like this, or you can leave it as x plus 0, but it essentially is just x. So you can write x. Remember, we have this thing, x, times x plus 1, times x minus 3. You'll multiply the left two parentheses sets first. So x squared plus x. You take that expression, and then you multiply by x minus 3. So x squared times x is x cubed. X squared times negative 3 is negative 3x squared. X times x is x squared. X times negative 3 is negative 3x. Combine like terms, so our final answer is y equals x cubed. And minus 3x squared plus x squared is minus 2x squared minus 3x. That is our equation. And we're done.